This is question 11 from tutorial sheet 4 for engineering dynamics. In this question, we're given a tram that's moving around a curved track, and we're given the mass of the tram, the radius, and its speed. And we're asked to calculate the centripetal force that the rail exerts on the tram wheels. This is the force acting towards the center of the rotation. So let's start off with our formula for centripetal force, which is force is equal to mass times angular velocity squared times radius. And let's see what the question has given us. We have the mass of the tram, it's 4 tons, and of course a ton is 1,000 kilograms, so this is 4,000 kilograms. We have been given the radius of the track, which is 300 meters, and we can keep those units because that's the units we like to use in these calculations. I've been given the linear velocity. So this is not what we need for the question, but it is what we have. That's 60 kilometers per hour. We can convert between linear and angular velocity using the following formula: V equals omega r. But before we do so, we want to have V in meters per second, and so we'll convert this to meters per second. From our earlier work in the course, effectively dividing by 3.6 because we multiply by 1,000 and then divide by 3,600 to convert kilometers into meters and per hour into per second. And this leaves us with 16.667, 3 decimal places, meters per second. Using our bridging equation between the two quantities, we can find that omega is equal to V over r is equal to 16.667 divided by 300. And I'm going to use the exact calculator value for V there and divide that by 300. And this gives us a value of 0.0556. Again, that's in radians per second. We're now equipped with all of the values we need to find the centripetal force, so we'll put it into our formula. So our mass is 4,000, omega is 0.0556 squared. I'll use the exact calculator value here, so there might be a slight variation if you use rounded figures, and we'll multiply by the radius of 300. Putting this into our calculators, what we come out with here is 3,703.703 newtons. Always remember our units, they're important as well. So that's a centripetal force acting inwards to the circle that has been turned by the tram moving around the curved track.